Okay, so this is lesson 4, pages 374 and 375 on proportional and non-proportional relationships. Okay, if you read through the first example, the real world link was talking about ordering pizza. At the top of this page, it finishes that example and it talks about, it gives you your vocabulary of proportional and non-proportional. Two quantities are proportional if they have a constant ratio. So the example was each pizza cost $8. Non-proportional would mean that it is not constant, as in the deal if you buy one pizza for $10 and then you get the next pizza for $5. That is not proportional. Okay, so all the ratios above are equivalent because they have the same value. Okay, so now let's talk through this example here. Andrew earns $18 per hour for mowing lawns. Is the amount of the money he earns proportional to the number of hours he spends mowing? Yes, because for every hour he earns the exact same amount. So I can take 18 and divide it by 1, 36 divided by 2, 54 divided by 3, or 72 and divided by 4, and I will continually get 18. So that is constant. Now if he earned a tip on top of that, then that would be would make that not proportional. Okay, so then all of the ratios can be simplified. They all are equivalent to 18. So let's look here at this example. So this says at Lakeview Middle School, there are 2 homeroom teachers assigned to every 48 students. Is the number of students at the school proportional to the number of teachers? So for every 48 students, there are 2 teachers. So the ratio of students to teachers is 48 to 2, or 24 to 1. If I took 24 and multiplied it by 2, I got 48. If I took 1 and multiplied it by 2, I'd get if I took 1 and multiplied it by 2, I'd get 2. So since the ratio is constant, the number of students is proportional to the number of teachers. Because then if I had 96 students and I divided it by 4, I would still get 24. So that would be another set of 48 students. Okay, so then let's go to the next examples, the other examples on the other page. So again, this one up here is talking about using the recipe to make fruit punch, and is the amount of sugar proportional to the amount of mix. Okay, so I said 1/2 to 1, 1 to 2, 1 and 1/2 to 3, and 2 to 4. It shows that each ratio is simplified to the same. So since the ratios between the 2 quantities can be simplified all to 0.5, it is proportional because that's a constant. Okay, so then here's another example. So at the beginning of the year, Isabel had $120 in her bank account. Each week she deposits another $20. Is her account balance proportional to the number of weeks she deposits? Use the balance or the table below. Explain your reasoning. So the first week she already had $120, so she made a deposit, which made her balance become, it was 100, and I'm sorry, the 120 plus 20. So she already had 120 beginning. In week 1, she added $20, so it became 140, then 160, then 180. Okay, so let's look. If I take and I divide 140 divided by 1, is that the same as 160 divided by 2? No. This would equal 140, and this would equal 80. So it is not proportional. It is not increasing at a constant rate. Not proportional. Okay? Because so to say that the ratios are not equal. Okay? And then to be proportional, To be proportional, there must be a constant change. That can go up or down, but it has to be constant. Okay, it can't go up by 20 and then up by 30, then up by 40. It has to have a constant change, like going up by 20 every time. Okay, so you're going to need to work on problems 1 through 3 on page 376. You can also read through again the example on page 376 about comparing the number of pages Martin read as opposed to Gabriel.